For years, we have struggled with diminishing resources, and too often we hear the words, something must be done. The diamond-shaped fluid-powered linkage system and engine is a solution. Using a time-honored, highly effective diamond-shaped piston combined with modern controls and tooling, the engine actually produces more energy than it needs to run.
Top face there is a force. So the pressure times that area develops a force, but the pressure's pushing out on the two sides as well. So you have two forces going this way, plus that.
Its inventor is David Strain. Founder and president of APS, Analysts of Pneumatic Systems Limited, David has had more than 3 decades of experience in control systems. He has saved companies millions of dollars with his control logic and energy strategies. The diamond-shaped fluid-powered linkage system and engine has been in development since 1971. Currently, it has patents in Europe, the US, and Canada.
Fundamental science of it actually was known a long time ago, that if a conventional piston and a diamond-shaped piston opposed each other, the diamond-shaped piston being more efficient would become more powerful, and it would overpower the conventional piston. Where we came into it is we developed a control system which allowed us to cause the fluids to flow such that when we expose the two of them to the same pressure, the diamond would overpower the conventional piston and you could extract the surplus work.
This is a pretty amazing claim. Is this just theory or does it actually work?
No, it does actually work, and it's based on the same principles as all hydraulics that we currently have in society. A hydraulic system works based on a force and counterforce within the actuators. And what we did is we had two actuators oppose one another and developed one actuator that is much more efficient than the other. And as a consequence, when they both are pressurized, the more efficient actuator forces fluid out of the conventional actuator in a volume that is able to feed itself. So he basically squeezes his own source of fluid out of the conventional actuator, and he only uses about 85% of his force to do that. And that is where we step over the line as far as laws of physics go currently. But it does work. I've built a machine that actually runs. When it drives forward, most men aren't strong enough to stop it as it's driving. So it overcomes all of its own frictional problems. It runs through its cycles and can push you out of the way while it's doing it.
What are the challenges of manufacturing a practical engine?
Okay, to do it in the workshop that I have, there are a lot of challenges. The hinges have been a significant problem with them bending, and diaphragms, the membranes inside, have broken quite regularly on us. But to move into a proper manufacturing facility, we're bringing in experts who are experts in materials and experts in structural mechanics and such. They all have their own specialty fields, and they will fine-tune each part of it. Now, what I say to people is the model that I built, which runs, is like a Model T with square wheels. It's clumping down a road. It proves that such a thing can exist. So now when we bring in the engineers who specialize in wheels, they'll say, don't have square wheels, have round ones. And the bearings will be improved and the diaphragms will seals. Now, I expect that there will be engineers somewhere who specialize in hydraulic seals, and we'll probably be able to build seals where we don't actually need a bladder inside. So all of those things they're just nuts and bolts problems. The main issue at this point in the game is convincing society that the physical laws that we believe to be true are not true. And then we can move ahead from there. It's a huge mental block socially, and we got to get past that.
When all the challenges are met, how can an engine like this be used?
Actually, I envision it being used almost anywhere where we're doing work. Anywhere electricity is doing work now, this could be doing that. They can actually be used to produce electricity by driving the generators. My preference is to actually do the work directly. So if you want to, say, if we wanted to irrigate fields with this, instead of arranging the ratios between the two of the actuators such that we could extract the maximum power, we would arrange it to create the maximum displacement of fluid. So then it would pump, say, 120 gallons of fluid out of the conventional piston. It only need 100 gallons of it to do the next cycle itself. The other 20 gallons can be pumped out to irrigate fields. That's one of the kind of favorite thoughts I have for it. Another point which I would like to think about is that we don't need to use nuclear plants anymore in the future. We can use these units to drive the turbines, and we get away from all the hazardous waste left over from nuclear fuels. So, and also we could I also envision that sometime we will have these units in each small town, which will negate the need for all the transmission lines that we have all over the province. So anywhere that we want work to be done, this will be able to do it.
How big an engine is conceivable here?
It could cover a tremendous range. You could have one that could be small enough just to run a lawnmower or a small appliance in your house, or you could have one large enough that could actually negate the need for using nuclear materials to run the power plants. A function of its power output is the pressure that you're running the system at. And on the website, you see the charts on that where we measured the internal pressure of the machine running, and it deliberately varied the pressure and showed the cycling rate increasing, decreasing based on the static pressure of the machine. So the output is based on two different functions. One is the actual pressure you're running it at, and the second one is the size of the actuators you're using. Now in actual hydraulics now, you can get units that are down as small as your finger, and you can get ones that are almost the size of this room. So the horsepower variation could be down from 1/100th of a horsepower machine up to maybe 500,000 horsepower or 1,000,000 horsepower. So there's a wide variation.
Who have you shared the concept with?
Okay, I actually shared it with many people. There have been approximately 50 different engineers and scientists who have looked at it to varying degrees. Most of them have been quite flabbergasted because initially they first don't believe what they're seeing, and then when they come to grips with the fact that what they're seeing is the truth, then they are usually quite amazed. We have some extremely positive responses from some PhDs who socially are about as high as we can get in the energy field. One's a PhD who's a professional engineer as well. So it's been very positive from that point.
David, it looks like you stand to make a lot of money with this invention.
Isn't the driving focus on this at all. From the very beginning, back in 1970 when I started working on it, had a deep concern for the future for the kids on the planet. And the focus is purely on trying to generate a situation of cleaner water and cleaner air for the kids. And compared to money, just no contest. If the kids have no water and no air, then money really doesn't matter, does it?
All right, David, thanks very much.
Thank you.
If you would like more information on the diamond-shaped fluid-powered linkage system and engine, visit the website at www.apscontrols.ca.